Hello students, welcome to the course Network Theory. In the previous video, we discussed a problem on superposition theorem. So with this problem, we try to explain how we apply the superposition theorem concept to a network, and also in elaborately we discussed the Kirchhoff's current law and Kirchhoff's voltage law. So that is nothing but the node analysis and mesh analysis, and when we use mesh analysis and node analysis, so that also we try to explain in single problem. Okay, so with this knowledge, so we try to see two more problems so in this video. Okay, so hopefully note down the second problem. Find VA using superposition principle in the circuit shown in figure below. So just note down the figure. So you have a 2 ohm, 17 volt, 1 amp, 4 ohm, 3 ohm and 5 VA. So this is a dependent source here, and these two are the independent source, one voltage source and one current source. Okay, and we need to find in this case now the voltage across 2 ohm resistor. So that is denoted as plus minus VA here. Okay, so this we need to calculate using now superposition principle. So that means what? First I need to activate this and deactivate this. That means this is an open circuit. So anyhow this resistor is in series with a current source. It does not have any much importance here. So it is trivial element or redundance element we say. It is no use. You can remove it or as it is. Okay, so it does not affect much in the problem. So this we have seen in terminal equivalent characteristics in source transformation. Okay, in the basic concepts. And second case, we'll deactivate 17 volt and activate 1 amp. So that means what? It will be made 0. That means it is a short circuit. Okay, so that is what the thing. So first case we'll call it as VA1, second case we call it as VA2, and then we'll both add the voltage. So that will give you the VA, that is the voltage across 2 ohm resistor. Okay, so the network will be new, but so your concept should be strong so that you can apply easily. Okay, so it is not any gate exam. So in gate exam and all, they won't mention also this what is principle you have to use. Just they will give the network and tell you to find out some voltage or current or power in the circuit. So there are many concepts are in network, so you need to go any simple method you have to solve. Shortcut method you will solve in competitive exam. But in this VTU examination, so your concept will be made strong. For that, they will mention using superposition. So this is easy compared to that. Okay, so superposition principle you apply and find out. Okay, so just we'll go through the solution. Okay, so first case. So as I mentioned, 4 ohm in series with 1 amp current source is a trivial element. That means it does not have any use in that branch. So first step in the superposition theorem is activating. So don't consider only two sources will be there. No, it will be n number of sources will be present in network. But for simplicity to understand the concept, normally 2 or 3 sources will be given. Okay. So 17 volt source is made active and 1 amp is deactivated. So when you deactivate that, so the equivalent circuit will look like this. So here current source was there, so that is removed. So this complete branch is removed. Okay, and now you have a single loop. Okay, and they have shown the plus symbol is here for the resistor and minus. So normally we'll take plus this side and minus that side because we take the current clockwise direction. But in this problem they only mentioned this is plus and this is minus. So that's why we need to change our current direction now and take clockwise. Okay, so current direction should be anti-clockwise because so like this means current is entering the element. So that means plus symbol it should enter. That means it is a power absorbing element. So resistor is a absorbing element. So always current entering that node should be plus. Okay, in case they have not given current direction, if they have given this plus here, that means current should go in this direction. Okay, so I have made mistake here, so just correct it. Okay, but equation wise there is no problem. Okay, as I shown you earlier, even if you take clockwise also here, no issues, nothing is going to happen. Okay, so don't bother about that. So now if we apply KVL here, what will happen? So you can use any convention now. Either you can use the first whatever comes that you can use, or you can take minus to plus as plus you can consider. Okay, voltage rise as plus, voltage drop as minus. Okay, that is quite difficult. You can go any method. So I consider now second convention today. So minus 5VA1. Okay, so minus is starting symbol. So minus 5VA1. So current direction is like this. So this will have plus minus. So minus So this is minus, this is plus 3i1. Okay, i1 is the current. Then here minus is there, so minus 17. Then here plus is there, plus 2i1 is equal to 0. Okay, so that I have written in the next step, so just you can clarify. So minus 5, so it is written in this clockwise direction. Before you can write this first minus 5 va1, then you have plus 3i1, so plus 3i1, and then minus 17, and then plus 2i1. Okay, so any convention you can follow. Okay, minus 2 plus s, if you consider plus, so plus va1, then minus 3i1. Okay, minus 17, then minus 2i1. Okay, so like that also it will come. Okay, so what will come? So what is va1 here in this figure? Okay, so va1 is nothing but the voltage drop across the resistor. Okay, so just we try to look at clearly, so otherwise don't confuse. So minus 2 plus, if you are considering this, plus va1 minus 3i1, so this plus 17, and this is minus 2i1. Okay, so the same thing, let it be anyhow. Okay, okay, so just you write as it is. Okay, so follow the convention, this is plus here. Okay, so make correction, maybe I have gone wrong. Fine. So now what is va1? As I told you, that is the voltage drop across 2 ohm resistor. So Ohm's law, 2 into r into I into r. So I is i1 here and r is 2, so that's why 2i1. So wherever you have va1, substitute 2i1. Okay, so this is 2i1 already, so minus 17, and this is plus 3i1. Okay, and this is minus 5 into 2i1 is equal to 0. So now add up, so what you will get? So plus 2 plus 3, so it is plus 5i1, plus 5i1. So here what you have? Minus 10i1. So minus 10 plus 5, so what you will get? Minus 5i1, right? Minus 5i1 is equal to, you have only 17, so minus 17, right? So this is taken right side. Okay, so 2i1 plus 3i1, 5i1, 5i1, minus 10i1, so minus 5i1, and the 17 is taken right side, means it is plus. Okay, but minus sign is there anyhow, so i1 is equal to minus 17 by 5 now, not 11, minus 17 by 5 amps. Okay, so this is the correct answer, so correct it. Okay, so then what you need to find here is va1. So va1 is 2i1, so i1 you got, so just 2 into i1, so minus 17 by 5, so you will get minus 34 by 5 volt. Okay, so make this correction. So either you can keep like this, or you can find it 5 6 the 30.45 just 6.8 volt minus 6.8 volt also you can write. Okay, anyhow, so it is your wish. Okay, so you can keep minus 6.8 volt only, no issues. So make this correction. So this is symbol, this was small mistake, because of that answer was wrong. Okay, so hope you have noted down. We'll do the similar way second circuit. Okay, so second voltage 17 volt is deactivated. Okay, the voltage source is deactivated, that's why this branch got short circuit here, and this branch has come, and that trivial element I just removed it. Okay, because finding current, no, so no use. Okay, voltage. So now here, since you have one node, okay, so this is, I have taken one, actually this is plus minus is there, meaning what? Plus minus va2 only it is there, means this is a va2 only. Okay, so at all this upper node you have the va2, so here also va2, here also va2, everything, right? And this is the reference node, ground node. Okay, it is at zero potential, but I have taken here v1 a separate node, v1, later we will equate it to va2 only. Okay, so I have taken v1 and I have written the KCL equation now. So if you write the KCL, and again also I have written straight away. So you have three branches here, this is one branch, this is one branch, and this is one branch. And as an assumption, in node, what we'll do, current is always leaving the node, we will consider. Okay, current always leaving the node. Okay, so with respect to that, now if we write the KCL, so VA minus 0, so this is going this side now. So VA minus, I will write a separate equation and then you write that. Okay, so the straight away written equation that VA minus 0 divided by resistor. What is the resistor value? 2 ohm. It is 2. So this is V1. Okay, V1 minus 0 by 2. Okay, plus you have this side, right? So this side you have another branch, you have V1, and this also plus minus is there. So it is V1 minus 5 VA2. Okay, so that is a dependent controlling variable now. That's why VA2 we have made earlier. VA2 by resistor value is 3. So previous case we have taken it as VA1 and we have solved it. Now VA2. Okay, minus this branch is there. So normally we'll leave the node, we will say. So it is current entering. That's why it is minus 1 will be considered equal to 0. So these are leaving the node. That's why it is plus here. And this is leave entering. So minus 1. If you rearrange this, what you will get? So V1 by 2. So this is correct. Then V1 by 3. Then minus 1 taken right side. And this minus 5 VA2 by 3 is taken right side. This is the second step. Okay, so I am writing straight away because I know, right? Okay, so you write this equation first so that you will understand, and then you write this simplification equation. So now what we have to do, this V1 is nothing but VA2, right? V1 is plus minus, so this is also plus minus here, same potential. There is no other element, only one element, so it is VA2. So wherever V1 is there, so you substitute VA2 and solve the equation. So V1 is equal to VA2. So wherever V1 by 2 was there, VA by 2 by 2, VA2 by 3. And now again this is taken left hand side, minus 5 VA2 by 3. So that we can solve it for VA2 equal to 1. Okay. So then take an LCM here, 6 is the LCM. So 2 3s are 3 VA2, 3 2s are 2 VA2, and this is 3 2s are 2 5s are minus 10. Okay, minus 10 VA2 is equal to 1. So this is cross multiplied in next step. Here 5 minus 10 VA2 is minus 5 VA2 equal to 6. So VA2 is equal to minus 6 by 5 volt, or it is equal to minus 1.2 volt. Previously you got minus 6.8 volt and now you got minus 1.2 volt. Okay, so since it is taken opposite, okay, so convention minus you are getting. Okay, so now as in superposition theorem, add both the voltages, thus the total voltage is equal to VA1 plus VA2. Okay, so here I have made mistake, right? So it is 34 by 5 minus 6 by 5, so it will be 40 by 5 and it is 8, right? So this is wrong, so this is wrong. Okay, because LCM, so you'll get minus 40 by 5 equal to 8, or if you use the straight away the values 6.8, 6.8 minus 1.2 is equal to minus 8 volt. Okay, so minus 8 volt is the answer. So this was wrong. Okay, so don't copy this. So mistakes will happen. Okay, so normally, so you should be careful taking the convention positive and negative. Okay, hope it is understood. Okay, so first problem we have taken with respect to current, now we have taken this with respect to voltage. Okay, anything they can ask. So with this knowledge, so we'll continue with another problem. Okay, so again we'll take the three sources now, so that you could not misunderstand that only two sources will be there. No, okay, it can be n number of sources. That's why we told complex circuits, right? We are applying the theorems. Fine. So note down the question. Find Ix for the circuit shown in figure using the principle of superposition. Okay, so they have told use superposition. Okay, so here you have 12 volt 2 ohm, 12 volt 4 ohm, and 8 volt 4 ohm is there, and you need to find the branch current of this branch, that is Ix. This you need to determine. Okay, so here no need to use like you have to use mesh analysis only, node analysis. No, you have learned whatever methods you can do. So far you have done source transformation, you have done series resistors in series, parallel, voltage divider rule, current divider rule. All these things will apply. Okay, source, star delta transformation, many things. Okay, so looking at the circuit, so you need to come to the any possibility. Okay, however, so your concept should be correct, then current will come correctly. Okay, so now we have three sources here. So now each cases you have to make each one of these source active and others you have to deactivate, and you need to find the three currents ix1, ix2, ix3, and then finally you have to add the current ix1, ix2, ix3. You will get the total current ix. Okay, so this can be done using now node analysis also, but here told superposition, that's why we have to go for that method. Okay, so we'll solve the solution. So hope you have noted down. You can pause it and note down also if you have not completed. Okay, so first one we'll make the first 12-volt source active. Okay, and remaining two we will make it as deactivated. So then your circuit looks like this. So 12 volt and 2 ohm is there. So here these sources are short circuited. Okay, here also short circuited. Okay, so now how the circuit looks like? A current divider circuit, right? So you have this voltage source in series with resistor, nothing but a current source in parallel with resistor, right? Anyhow, so here you have the total current I now coming from this branch, because voltage is there, no? So current will be there. So here 12 by 2 is 6 amps. So 6 amp current is coming, you can consider. And you have the two branches, right? So you can use the current divider rule here to find out. So for that, first you need to determine the current I here. Okay, so how you determine the current I? So what we'll do, so this resistors equivalent we will find out. Okay, what is the equivalent? So here this 2 ohm is in series, right? So at this junction it is in series, and then these two became parallel, right? So whatever current leaving here and whatever current entering here, it is same, right? So in between, so 2 ohm is in series and these two are in parallel. So that's why series it will be added 2 plus. Then parallel you have to take the equivalence, reciprocal of 1 by r you have to take, right? So 1 by r is 1 by 4 plus 1 by 4. So it will give you the answer 2. 2 by 4, 4 by 2 is 2. So 2 plus 2, 4 ohm. Okay, so then I is equal to 12 by r equivalent. 12 is the V and r is 4 you got. So current is 3 amps. So now you got the total current 3. So now you use the current divider rule here. Okay, so I'm not using any mesh analysis here, it will be lengthy. So current divider rule simply will give you the current ix1 excluding this. Okay, so I will consider the, okay, so this branch current I have to find, means total current I, that is 3, into opposite branch resistance is 4. Okay, divided by total resistance, 4 plus 4, 8. Okay, so what you got? 12 by 8, which is 3 by 2, equal to 1.5 amps. Simple. Okay, so just to show you, only not only mesh or node analysis you can apply, other methods also you can apply. For that this example was taken. Okay, similarly we'll do the second source active, that is 12 volt with 4 ohm will make active, and remaining will deactivate. That means they are short circuited because voltage source. So now just it is shifted to this, so no changes here. So now how you write? So R equivalent is 4 ohm. This 4 ohm is in series with these two resistors. So they are 1 by 2 plus 1 by 4 you have made. So it is 3 by 4 or 4 by 3 it will come. So 4 plus 4 by 3 will give you 16 by 3, which is equal to 5.33 ohm. Not exactly 4, 5.33 or 16 by 3 only you can keep. So now current is 12 by that equivalent resistance. It is 5.33. So that's why now the current is 2.25 ohm. Okay, so although resistor values not change, but how they are connected, right, with respect to this branch it is changing. Because of that it is changing, and because of that current is also changing. Okay, so this is 2.25. Okay, so if you take 16 by 3 here, so it is 36 by 16 something coming, and then you take the ratio, you'll get 2.25 amps. Okay, so finally the third value, so 1.5 you got, 2.25 you got. Next we will make the third voltage source active, 8 volt source active will make. So this, and then what we will get? So you have this 4 ohm in series with these two resistors, right? 1 by 2 plus 1 by 4, same as previous one. You will get 16 by 3, 5.33 ohm. Okay, and now current here in this case is 8 by, earlier it was 12 by was there. So now it is 8 by 5.333. So it is getting 1.5 amps in terms of total current. So now again we'll use the current divider rule here Previously also we have used. So previous case it was there in the branch itself, right? So that's why it is not used. Okay, so just to clarify. So this total current only the branch current here. Okay, previous case. That's why you have not taken any current divide rule for this branch, because in this branch only this current is there, right? That's why that is the current, total current. That's why further steps you are not done. Okay. Whereas now it is in different branch. You have to find the current in this branch, but this total current is in this branch, right? That is 1.5 amps. That's why again we are using the current divider rule. Okay. So hope it is understanding. So just go through the first part again. If you are not understood using current divider rule. So total current 1.5 into branch, opposite branch resistance is here 2 now. Okay. So 2 divided by total resistance 2 plus 4. So it is 3 by here 2 by 6 will come. So 2 into 1.5, 3 by 6, it equal to 1.5 amps. So you got the 3 currents using one of the source active. So now you have to find the total current Ix is equal to Ix1 plus Ix2 plus Ix3. Ix1 you got 1.5, then 2.25 and 1.5 you, 0.5 you got. So it is 2 plus 2.5, so 4.25 amps. Okay. So this is the method of superposition to calculate the current Ix. Okay. So 8 marks they will ask. Okay. So this is how you will do. So with this we are completing the concept of superposition theorem. Okay. There are plenty of problems are there in notebook, everything. Okay. So various methods are there, but theorem concept will not change, right? So you have to first identify how many independent sources are there, voltage or current source. So accordingly you should take that many number of steps, and you have to note down the voltage or current whatever they have asked, and finally you have to add up those individual currents to get the total current or voltage. That is what the concept of superposition. Okay, fine. So we'll go through the next theorem in the next video, that is Millman's theorem. Okay, a very simple theorem again. So we'll look at in the next video. Okay, thank you. We'll see in the next video.